Welcome to Lesson 3, Module 3, Comparing and Ordering Rational Numbers. Right, so today we're going to talk about interpreting statements of inequality as statements about the relative position of two numbers on a number line diagram. And we're going to write, interpret, and explain statements of order for rational numbers. So basically this is going back to what we did with integers, but now we're doing it with rational numbers. So we're involving decimals and fractions. So what this means here is we're taking a look at how does the placement on the number line impact whether a number is larger or smaller than another number. All right, so first what we're going to take a look at is fractions and decimals, and realizing that even though they look different, they mean the same thing. So you have fractions that are equivalent to specific decimals and vice versa. So let's take a look at this number line here. If we look at the top, we have all of these decimals, and if we go across, we can see the pattern here. So it's 0 and 2 tenths, 0 and 3 tenths, 0 and 4 tenths. So the next one will be 0 and 5 tenths, and I'm actually going to erase that and get a smaller and different color pen here, make it a little easier. All right, well, at least it's smaller. All right, so now we know that the next one would be 6 tenths, 7 tenths, and here would be 8 tenths. And then if we go backwards, we know that the first one would be 1 tenth. Well, look at here, 1 tenth as a decimal is the same thing as 1 over 10 as a fraction. I know we spoke about this before. If you say the decimal and you say the fraction, they should sound exactly the same. So even though there isn't a 0 written here, there actually is a 0 here with that decimal. So this is 0 and 1 tenth, and this is 0 and 1 tenth. So then here, since this is 2 tenths, we know that as a fraction it should be 2 tenths. Okay, and then we have 3 tenths. Now here we would have had 4 tenths, but we know that we can reduce 4 and 10 both by 2, and we can get 2 over 5, so we would get 2/5. So not only is 4 tenths equivalent to 4 tenths as a fraction, but it's also equivalent to 2/5. Right? Here we also have 7 tenths as a fraction. Okay? So then now, looking at this, we know that, again, 6 tenths would be 6 tenths as a fraction, and then we can reduce it to 3/5. So all of these, so 0 and 6 tenths, is equivalent to 6 over 10, which is equivalent to 3 over 5. All right, so just because they're in different forms doesn't mean that they can't be equivalent. So now here we're going to look at B. We're going to use the number line to find the fraction that is equivalent to 25 hundredths. So now here, I know that 25 hundredths, so here's 2 tenths and 3 tenths. Well, if I extend those out, this would be 0 and 20 hundredths, because we can always add those zeros as long as it's after the decimal. And this would be 0 and 30 hundredths. So 25 hundredths would be directly in the middle of 2 tenths and 3 tenths. So this would be 0 and 25 hundredths right here. Right? And then according to the number line, I know that 1/4 is going to be equivalent to 25 hundredths because it shows me that 1/4 is listed right here. Okay, so for our explanation, since 0 and 25 hundredths is halfway between 2 tenths and 3 tenths, and the number line shows that 1/4 is also halfway between those numbers, we can conclude that they are equivalent. Okay, so explain how to use the number line to find a decimal equivalent to 1 and 7 tenths. Well, I would find 1 and 7 tenths on the number line and then look above to see what decimal it is equivalent to, or what decimals it falls between to determine what it is equivalent to. So now here's the thing. This is all based on the idea that the number line is going to have fractions and decimals and is going to show us which ones are equivalent. So this is just using the number line. So if I look here, I know that using the number line, 2/10 is equivalent to, as a decimal, is equivalent to 2/10 as a fraction, but if I reduce that, it's also equivalent to 1/5. I know that 3/10 as a fraction is equivalent to 3/10 as a decimal, or even 0 and 30 hundredths. 75 hundredths, so now again, we're looking here, this is 0 and 70 hundredths, and 0 and 80 hundredths, and we're looking for 75 hundredths. Well, I know that that's halfway between 70 and 80, which is actually 3/4. So I know that it is equivalent to 3/4. And then 1 and 25 hundredths would be equivalent to 1 and 25 hundredths, or 1 and 1/4. Okay, because since I know that 25 hundredths is between 2 hundredths and 3 hundredths, I know that if I extended my number line out, it would be the same thing here, except for it would be 1 and 20 hundredths and 1 and 30 hundredths, and that 21 and 25 hundredths would be halfway between. And I know that halfway between is that 1/4, so even with the 1, halfway between that 1 and 20 hundredths and 1 and 30 hundredths would be 1 and 1/4. Yeah, but we're not always going to have that number line, all right? So here we can look at and name the decimal, or name a decimal between 4/10 and 5/10. Well, any decimal that is, so we can even say 1 and 41 hundredths, or I'm sorry, 0 and 41 hundredths, 0 and 42 hundredths, 0 and 43, 0 and 44, 0 and 45, etc., etc. We can even extend that number out and say 410 or 0 and 4. So basically, as long as it starts with a 4 and doesn't get past starting with a 5. So once it gets to this, we're too far. So this one would not work. But anything that starts, that has that 4 in the tens place, no matter what's after, is going to be between the 0 and 4/10 and the 0 and 5 hundredths. Okay, and how does the number line represent equivalent fractions and decimals? Those equivalent fractions and decimals line up with one another on the number line. That is how we know they are equivalent. Okay, so if they line up on the same spot on the number line, that tells us they have to be equivalent. All right, so moving right along to example 1. So here I want to order these different numbers: 2/10, 3/4, 8/10, 1/2, 1/4, and 0 and 4/10. But now here's the thing, they're all different, and I don't have a number line. So when we talk about comparing, we want to compare apples to apples. So we have two options. In example 1, we're going to change all of our fractions to decimals. Okay, so 2/10 is already written as a decimal. What I'm going to do is I'm going to take all my fractions and I'm going to convert them to decimals. Okay? And I know that in order to do that, I have to use long division. And so here, for 1/4, I would do 1 divided by 4. 4 goes into 1 0 times. I add that decimal. 4 goes into 10 twice, and that's 8. And I subtract, and I get 2, add a 0, bring it down. 4 goes into 25 times. I have nothing left over. So 1/4 as a decimal is 0 and 25 hundredths. Okay, 1/2. Now these are all ones that I actually believe that you should know off the top of your head, But for right now, if we're not sure, we just divide. 1 divided by 2, 2 can't go into 1. I add those decimals. 2 goes into 10 5 times, and I get 0. So I know that 1/2 is equal to 0 and 5/10, which I know 5/10 is equivalent to half. So I know that that will work. And then here I have 3/4, so I have 3 divided by 4. Again, 4 can't go into 3, so I know I'm doing it right because I have that 0 in front of the decimal. 4 goes into 30 7 times, minus 28 is 2. Add the 0, bring it down, goes in 5 times, and I get 0 left over. So 3/4 is equivalent to 0 and 75/100. Now I can plot them all in a number line, and I can see their order, okay? Because 25/100 is larger than 2/10, and then I can plot the rest of them. Or what I can do is I can actually list all of my numbers now. So I have 0 and 2/10, 0 and 25/100, okay, because that's the 1/4. I have 0 and 75/100, which is the 3/4. I have 0 and 8/10, which was just listed before. I have 0 and 5/10, and I have 0 and 4/10. Since I know that I'm going from least to greatest, I look at this first row right here. Now I know since these three numbers end in the tenths place, I'm going to add on an extra 0 to see if they're actually smaller or not. So now here, because this has a 2 and this has a 2, I have to compare out to the second column, which this has a 5 and this has a 0, making 0 and 2/10 my smallest. And then 0 and 25/100 being my next smallest. But 0 and 25/100 was equivalent to 1/4, so I have to actually write 1/4 on my list. Okay, so now those two are gone, and I have no more 2's, so I look, my next smallest number is this 4, and it is actually listed as 0 and 4/10 on my list, so my next smallest number is 0 and 4/10. And then I look, okay, so then there are no other 4's, so I look and my next one is 5, 0 and 5/10, but I know 0 and 5/10 I said was equivalent to 1/2, so 1/2 is my next largest number. Okay, and then I'm going to go ahead and cross that one off my list. So now my next one has 7 in the tenths place, and even though it goes out one further than the 8 does, because 7 is smaller than the 8, the 75/100 is smaller, meaning the 3/4 is smaller. So 3/4 is my next smallest, and then 8/10 would be my next smallest because that's all that I have left. Okay, so what I can do is I can take them and turn them all into decimals and then compare the decimals. Or looking at B in example 1, I can take them all and turn them into fractions. So now 35/100 as a fraction would be 35 over 100. And I'm going to reduce that by dividing them both by 5 to get 7/20. Okay, so divide by 5, and I get 7/20. Well, now I have 1/12, I have 2/3, and I have 7/20. In order to compare them, all of these have to have a common denominator. And in this case, 60 is the least common denominator. So I'm going to change all of these to have a denominator of 60. So to do that, I start with 1/12. I know that to go to 60, I have to multiply by 5. And what I do to the top, I do to the bottom. So I get 5/60. And then I know that to go from 3 to 60, I multiply by 20. And what I do to the top, I do to the bottom. And then in order to go from 20 to 60, I multiply by 3. And what I do to the top, I do to the bottom. So now the numbers that I have to compare are 5/60, 40/60, and 21/60ths. And I want to go from least to greatest. Well, now, since all my denominators are the same, I can just compare the numerators. Well, the one that has 5 out of 60 is going to be the smallest. And then the one that has 21, and then the one that has 40. So I know 5 is less than 21, which is less than 40, which means that with my equivalent fractions, 5/60ths is going to be less than 21/60ths, which is less than 40/60ths. However, I have to go back to what these actually represented the first time. So 5/60ths, and actually I'll write it here so it makes more sense, was 1/12. So 1/12 is my smallest. 21/60ths was 7/20ths, which was actually my 35/100ths. And then 40/60ths was the 2/3. All right, so from least to greatest, it's 1/12, 35/100ths, and 2/3. All right, so now you can pause and take an opportunity to try this on your own, and then when you come back, we'll check your answers. All right, so to be honest with you, what I would do is I change my fractions to decimals because then I don't have to make common denominators. Okay, so I know 3/5 is equal to 6/10, which would give me 0 and 6/10. And then 15/100 would be equal to 0 and 15/100. And then, which I don't know why I did that, scratch that, that was already one. 7/10 is already with a 10, so we have 0 and 7/10. So I have 0 and 85/100. I have 0 and 6/10. I have 0 and 15/100. And I have 0 and 7/10. And I'm going from least to greatest. So I'm looking for the smallest, so I have to look at my first column. Well, the smallest number is 1. So that first smallest number is going to be 0 and 15/100. The next smallest number is a 6, but this 0 and 6/10 was not written that way. It was written as 3/5. So my next smallest number would be 3/5. The next smallest was 7/10, but again, it wasn't written that way. It was written as a fraction. And then the largest was 85/100. Now, if I did this writing it as fractions, it would be 85/100. And then again, 3/5. And then 15/100. And then 7/10. I would make these so all denominators are 100. Okay, because typically changing them using multiplication is just easier. So I multiply by 20, multiply by 20. So this would give me 60/100. Multiply by 10, multiply by 10, and this would give me 70/100. So then I would just compare numerators, and I know the smallest would be 15, the next smallest would be 60, the next smallest would be 70, and the next smallest would be 85. And then that would allow me to put my numbers in order from least to greatest, which it would be exactly the same. All right, so now when you have negative numbers, it's the same idea. You either need to change them all to fractions or all to decimals. And we're going to change them all to decimals. Okay, so 1/2 we know is equivalent to 0 and 5/10. And then I know negative 1 and 1/4. Well, 1/4, I remember when I did 1 divided by 4, it gave me 25/100. So then 1 and 1/4 would be equal to 1 and 25/100. Now, since that's negative, there would be a negative in front of each of those. So negative 1 and 1/4 would be equal to negative 1 and 25/100. Now I can go through and I can compare them and put them in order. I can put them on a number line, okay? But what I want to do is I actually want to compare them based on their numbers. So here I have, instead of 1/2, I have 0 and 5/10. And here I have 1 and 25 hundredths, but it's negative. Okay, so my smallest number is going to be the negative 2. Okay, so the negative 2 is smallest because of the fact that it is furthest to the left. All right, so I'm actually going from greatest to least, so I know this has to be my last number. That's why we have to make sure to read directions carefully. I missed that we're going from greatest to least. So my largest number, so here's 0 and 5/10. Well, this one is bigger because it has a 1. Well, this one is actually bigger because here where I have, even though I have 1 and 4/10, this has a 9 and this has a 4. So 1 and 95 hundredths is actually going to be larger. And we know that on the number line, it's furthest to the right. So that's why it's going to be the largest. Then the next largest is going to be the 1 and 4/10, because I'm just working my way towards the left. Here I have 0 and 5/10, which was actually 1/2. And then my next is going to be, excuse me, the negative 1 and 1/4. And then the negative 2. Again, it's the same idea as integers. The further to the right it is, the larger it is. The further to the left it is, the smaller it is. So again, in negative world, negative 2 is smaller than the negative 1 because it's further away from 0. And it was easier to do this because all of our numbers were written as decimals. All right, so here we're going to order from least to greatest. I want you to pause, try it on your own, and then come back and check your answer. All right, so you should have found that 1 and 2/5 is equal to 1 and 4/10, which is equal to 1 and 4/10. 1 and 9/10 is exactly what it sounds like, 1 and 9/10. Okay, and that's it. So now I have negative 1 and 8/10. I have 1. I have 1 and 4/10 because I'm just listing them here. I have 1 and 9/10. I'm going in the same order as I have up here. And then I have negative 1 and 25 hundredths. But now I'm going from least to greatest. So even though all of these have 1, I have to look first at the negatives. Okay, so my negatives are negative 1 and 8/10 and negative 1 and 25 hundredths. So those are going to be my two smallest. So I can take those out right now. To determine which one's smaller, I have to look at that tenths place. Since 8/10 is larger than 2/10, that means it's further from 0. So that tells me that negative 1 and 8/10 is the smallest because it's further away from 0, which tells me that next it has to be negative 1 and 25 hundredths because that's my only negative number that is left. Now I can order just looking at my numbers. My next smallest, well, here I have decimal 0 because there's nothing here. So 1 has to be my next smallest because both of these have something in the tenths place. So this is like kind of like saying I have $1, $1.40, and $1.90. Well, obviously the person that has $1 has less. Okay, and then the 1 and 40 hundredths. So 4 is smaller than 9, so that would go next. But that was actually equivalent to 1 and 25 hundredths, so that's how I put it in my list. And then my last one was the 1 and 9/10. And again, the big thing is changing them all to being the same type of number. So all fractions are all decimals. All right, so you have a lot of problems here to practice. I want you to please show your work on a separate sheet of paper and just write your answers here because you're going to have to show your work in terms of turning this, so like here, 2 and 4/5, turning that into a decimal. Okay, if you want to, you can change your fraction to a decimal or a decimal to a fraction, whatever you're most comfortable with, but you have to show your work for that. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.